What's up, guys? I feel like it's been a while since we've had a video, but this next section, this next transformation is one of the trickier ones. It's not horrible, but it is a little bit more challenging than reflections and translations. So we're going to look at rotations. A rotation is exactly what it says. A transformation when a figure is rotated or turned about a fixed point. So if I were to like take an object and just turn it. So like with reflections, we flip it, right? Flip it like that. But here we're just taking that object, ooh, there we go, and just like turning it, rotating it a certain amount over a certain point. So the center of rotation is a fixed point. So say if I were to rotate it around this point, this tip of the pen, and I just rotate it. A rotation, again, doesn't change the shape of the figure, it just changes the position. So the shape, the pre-image and the image are congruent. Rotations we describe in degrees and directions. So we would say like 90 degrees clockwise or 270 degrees counterclockwise. So the direction, if I'm going clockwise, so well, let me think. I'm trying to think of how so it's like to your right basically is clockwise, to the left would be counterclockwise. So you guys can watch this really quick.
The graph shows triangle ABC with vertices at A, 4, 5, B, 6, 8, and C, 6, 5. A rotation is a transformation that turns a figure around a fixed point called the center of rotation. In this case, vertex A will be the center of rotation. Rotations can be described by direction. A clockwise rotation turns to the right. A counterclockwise rotation turns to the left. Rotations can also be described in degrees. For example, a rotation can be described as 90 degrees, 180 degrees, or 270 degrees. Rotate triangle ABC 90 degrees clockwise about vertex A. Vertex A is the point at which triangle ABC is rotated, so A prime will be in the same position as A. Point B is rotated 90 degrees, and point C is rotated 90 degrees. Next, let's rotate triangle ABC 180 degrees about vertex A. In this example, we will rotate counterclockwise. Since vertex A is the point at which triangle ABC is rotated, A prime will be in the same position as A. Point B is rotated 180 degrees, and point C is rotated 180 degrees. Finally, let's look at an example of a 270 degree rotation. Rotate triangle ABC 270 degrees clockwise about vertex A. For each rotation about vertex A prime will be in the same position as A. Point B is rotated 270 degrees, and point C is rotated 270 degrees.
Okay, so I think you can already see that this is going to be slightly more complicated. So we'll look at several examples together. And this, by the way, is on page 456 in your book. So you can go to page 456 and follow along and fill this in. But if we want to rotate a triangle, so here are the vertices of the triangle, and we're going to rotate it counterclockwise 180 degrees about vertex L. Then here's what we're going to do. First of all, we have to graph the figure. So given the 3 points, let's put L, M, and N on the graph. Okay, so we're going to graph the original triangle. Then our next step is we're not going to use a protractor. We're just going to kind of eyeball 180 degrees. So you're just going to draw a line through ML, okay? So we're going to draw a line through ML, and you can see that this segment is 1, 2, 3 units, so we're going to go 3 units this way to mark M prime, and you can see that from M to M prime, we have an angle of 180 degrees. So all you're going to do is draw a line through that segment, and with L as our center, this point L is going to be the same as L prime. M to get M prime, we just draw a straight line and then go the same distance on the other side. And then we're going to do the same thing with N. So we are going to draw a segment on this side of the triangle. And if you can kind of see, like, you don't really need a ruler if you can see that this kind of goes through 3 squares diagonally. So we're going to go through 3 squares diagonally right here to draw n prime. And then once we have all of those, we will connect them to make our new triangle, L prime, N prime, and N prime. So again, you can see that we're taking that original triangle right here and we're just going clockwise, so to the left, 180 degrees. So it's not a reflection, it's not going to be kind of oriented the same way as it is with a translation. A good way to check is if you look at M and N prime, between those 2 points there's a 180 degree angle. N and N prime, there's a 180 degree angle. Since this is our center of rotation, we don't have to compare those, but that's kind of a good way to check to see if you have graphed it correctly. And again, that angle should go counterclockwise, so to the left. So let's look at another example here. This one, we want to graph a figure and its image after a clockwise rotation of 90 degrees about vertex J. So how that's going to work is first we need to this would be a little bit easier with a protractor. First we need to graph all the points. So 3, 1, 3, 1, 3, negative 3. So here's J. Okay, just watch the rest of this video. We'll do some more examples together in class, but this will give you a good idea at least of a few, and then we'll look at some more in person. It'll just be easier. Go to page 458. So the nice thing is we can actually use coordinate notation to make the rotations a little bit easier, in particular when we're rotating about the origin. So if you look at that example, the center of rotation was 1 point on the graph, but your center of rotation is not always going to necessarily be one of these points. In this case, we're looking where the center of rotation is the origin. So if the center of rotation is the origin, and we want to rotate it 90 degrees, okay, this one is a clockwise rotation, so 90 degrees clockwise, well, the x-coordinate of the original, the x-coordinate of the image, I should say, the final one, is the same as the y-coordinate of the pre-image, and the y-coordinate of the image is the opposite of the x-coordinate of the pre-image. So the nice thing is, if it's a 90 degree rotation about the origin, we don't have to guess and like draw pictures to see what it is. It's always going to be this. The x and the y switch and the x becomes the opposite sign. If we have a rotation 180 degrees clockwise, then xy becomes negative x, negative y, or the opposite of x, the opposite of y. So every point, notice that the x would be negative here, y is positive here, x is positive, y is negative, so they each get the opposite sign. Coordinate notation for a 270 degree rotation, xy becomes the opposite of y, and then x. So for all of these rotations clockwise, this will always be the coordinate notation. So if we want to rotate using coordinates, here's triangle DEF, and it's rotated clockwise 90 degrees about the origin. Okay, so when rotating a point, I'll just kind of go through here so you can fill the notes. This is on page 459. When rotating a point 90 degrees about the origin, the x-coordinate of the image is the same as the y-coordinate of the pre-image. The y-coordinate is the opposite of the x-coordinate. So this is again y. Why doesn't it? Let's see here. Y, and negative x. There we go. So all we have to do is take each point and flip-flop the x and the y, and then change the sign for the x's, okay? So if we want the coordinates of D, E, F, and we want to write the coordinates of the image, then again, we're going to flip the x and the y. So the y goes first now, and then the x, this -4 becomes a +4. This -1 becomes a +1. This -3 becomes a +3. So they switch spots, and the x we take the opposite of. So this is a clockwise rotation over the origin is what that looks like. So if you look at the last thing for this section, and again, we will definitely look at more of these in class, but this gives you a good start, and so we don't have to go over everything together. If you look at the last one on page 460, this one now, we already have the rotation. We want to describe the rotation, and we're going to assume it's clockwise about the origin. So if we're looking at these points, and then we end up at these points, what rotation was it? Was it 90 degrees, 180 degrees, or 270 degrees? So it will be helpful for us, first of all, to write the coordinates of both of these. So the coordinates of, and this is the easy part because the coordinates of the original, A is negative 1, 2, 3, 4, 5, 6, -6, -2. The coordinates of B are -1, 2, 3, 4, 5, -5, 1, and C is -2, -3. Now the image, C is 2, 3, A is 1, 2, 3, 4, 5, 6, 2, and B is 5, -1. So if you look at each of these, the x and y are in the same position here, but they're exactly opposite of each other. So what is the one, if you go back to page 458, which one do x and y stay in their same spot, but they have the exact opposite sign? Well, that one was a 180-degree rotation over the origin. So this is a 180-degree rotation. So you guys try those check problems under each example. I am going to check to see the check problems are done, at least attempted, and we will definitely be spending some more time on this section than we did on the other two sections, just to make sure you guys get the hang of it. But at least attempt those and see how you do. So I want to see all the check problems, and I want to see your notes filled in, and you should have check problems done on page 457 and page 459, if you can read that, and 460. So have all those done, and I will see them and check them to make sure you got this homework done. Okay, that's all.